All right, so what I'll be doing in today's video is sharing with you all of the steps for creating this set of stairs. The idea here is to create a script where not only can we create one with the line segment that's parametric, but we can also input a different line segment and we can change the location. And within the script, we can change the sliders to create different iterations and different options for the design. If you're not interested in Grasshopper, a lot of the steps that you see laid out here in the script can be used to create that same model within Rhino. But what makes it useful to do it parametrically is that you can change all of the sliders and see the changes right away, where in Rhino, it might take a while for you to create the same iterations that you see here. So hopefully you're excited to see and learn a bit more about parametric modeling. It's very useful to automate designs, but also learning a different way of modeling is going to be useful in the future, and also be useful because you can use this over and over again and even share it with people. So thank you for being here. Hopefully you're excited to see what this is all about, and let's jump into the tutorial. All right, so let's start with the tutorial here. The first thing we're going to do is bring in a parametric point. What I like to do is use the construct point. Now that we have construct point, I route it through a point component so we can change the location. And then the third component is going to be SDL, which is a line defined by the start, the direction, and the length. So I'll plug this into the start. The direction, it could be in any direction. I'll just go to X. And the point here is to create this so we can apply any curve or any line segment going in any direction. So now that we have this, we're going to now create a slider for the length. So now with this slider, this is going to be the overall length of the stairs. Then the next component is going to be extend curve. So this is actually one of my favorite components that I've been using a lot because it lets you not only extend it, but also shorten the length of a line segment. So we'll plug in that line into the curve input. Then the start and end are going to be in the opposite direction. So I'll bring in a negative component and then use this to shorten on both ends by a specific number. So we'll use 60 here. Notice now that we have this first line segment, the original one, then we have the shortened one. Now we're going to be using shorten or extend again. And you're going to see that this is going to create the slope for it. So what we're doing is creating the base geometry here first. This way we can connect it and then update the script accordingly. So we'll take this line segment, bring in the endpoints of this line, then also bring in the endpoints of the second line that we scaled down. And now between the start of this one and the start of this one, we'll create a line segment. And we'll do the same thing with the end. So we'll copy this by tapping Alt. And now we've created a line segment at the beginning and at the end from those two. Now we have this other one here. That's going to be a set of endpoints that we want. But what we'll do is we'll take these two line segments and move them up by the height of the stairs. So let's go to a move component, Z vector to move it up. And we'll bring in a slider for the amount that we want to move this up. And I'll copy that and do that to both sides. And I'd like to keep them in separate components. This way we can connect them individually. Otherwise, we would have to re-select them using list item, and it's not as efficient as doing it this way. So now you're seeing that we moved this set of line segments from the beginning, and then the one that we shortened again, we are now going to bring in the endpoints from these two. And we're going to connect the start with the endpoint of this one. And now with the endpoint, we're going to connect it to the start point of this one. Or it's actually going to be the endpoint of that one. Okay. So depending on how you organized it between these two, that's how you would plug it in. So if you do this, if you use the start and end points switched on these, that's where you might have a separate or a different way to plug these in. But the idea is to create and join this line segment with this slope and this line segment. So now we're going to join those curves. And using Shift, we can add more inputs. So here we have the bottom one, the two sloped ones, and then the original or the other two that we moved up. So holding down Shift, like I said, we're going to go into the join curves. So I plugged in the transform into it, so that's incorrect. Let's undo that. So this line segment, the geometry, holding down Shift, I can add that input. Now we're going to do the same thing with this one. So now we have 5 curves, 1, 2, 3, 4, and 5. And the output is going to be one polyline. So I do like to flatten this. And this is even like a script that can be individual just to create this kind of slope. Then the idea here is to do a fillet to round the edges here. So let's go here to 24. What happens, and you're seeing this here, is that at some point you can't do the fillet to this one, but it will continue and add the remaining fillet to the next one. So that's just something that happens when you use the fillet curve component. But this is going to be the part where we are done with the base geometry. So it's going to move this to organize it a little bit. It is important to keep things organized. Now with join curves, we're plugging in things from different places here. So I do like to go to wire display and hide it. I'll do the same thing to the start and to the endpoint, or to both of these start points. We can always select it and see the inputs, so that's not that big of a deal. Now let's hide the steps from before. And I'll select them, middle click, or scroll wheel click, and then use disable preview. So what have we done so far? We have the original line segment, which is going to determine the overall length. Then we have the first offset, which is how far the first offset is going to be here at the top. Then we have this one, which we can keep it at 0 because then it would just move it down vertically. But this also creates a slope if we do want that option. And then this is going to be the height of how tall that is going to be. So we're going to be creating stairs here, but the idea is that you can even turn this into a cluster, which means that you can have this be created with any set of stairs, and we can still change the direction of that line segment. So if I go here and notice that everything is designed off of this line segment. So if I double click on this output, now everything is coming out of this relay. And if we go here to a curve component, which is an empty curve component, it's asking us to place one there. I'll right click it, go to set one, and then override that. And notice that it'll create it in any direction. Now there are limitations, like you can't use a curved segment. And if you can, it's going to, oh no, it does work with any line segment. Okay, so that's great. This could be used in not just a linear way, but with a curved segment. Now, the idea with the tutorial is going to be to keep it simple and do it with the straight one, but making sure that it has additional functionalities is also very useful. So let's clear the values here. Delete those inputs. And now let's move on to developing the rest of the stairs. With what we already have, we can continue here. So let's go back to this line segment. We know that everything comes out of this relay. So what we'll do is we'll take this, we'll plug it into a curve component. And we'll take this and we're going to move it in the Y direction. Now here's the thing. If we move it in the Y direction, if we ever want to plug in a line segment in any direction, it will use the world XY vector to do that. So we don't want to have that issue later on. So what we need to do is take this curve, bring in a horizontal frame, which what it does is it will set a reference plane relative to this line segment. So let's plug that in. Now the parameter input, it's between 0 and 1. So if I want to make sure that it's in the middle, I'll go to 0.5. So let's plug that in. Notice that it creates that there. And if we change the direction, like I said earlier, to a different one, then it will put it there. Now, notice that on this line segment, it's putting it all the way at the beginning. That's because we need to reparameterize the input. So now we can use this frame or this construction plane as our reference to move this line segment. So let's zoom in here. This is going to be the X direction. This is going to be the Y direction. So I'll deconstruct this plane. So this construction plane, I'll deconstruct it so I can use these vectors to move that line. So I'll go to amplitude. This will allow me to plug in and the magnitude or the amplitude of the Y vector. The Y vector is going in the positive direction, so that's okay. And now I'll bring in a move component and move this line segment, which is the one that is creates the original geometry, in that direction. Now we can plug in an amplitude or a magnitude for that vector, which is going to be a slider And now we're going to move this up in the Z direction. Now, with the Z vector, we don't really have issues because up and down are going to be a constant, as opposed to the direction of the line segment. That's going to be something that varies. So we'll copy the slider, bring it up. And now we're going to tie it to the height of this line segment that we moved up. So this number is going to be the same number that we use for that movement. This way we make sure that they're on that same height relative to the start and the end of the stairs. Now I'm seeing here actually of a different way of doing this, which would be, rather than moving it, since we do want to be able to use a curved segment, we could offset that curve. This way, if it's curved, when you move it, it's not going to be shrinking in the direction where it curves. But this way, we'll do it for now, just letting you know that there's another way of being able to offset this line segment. We could just use an offset curve. Okay. Now we're going to hide this one, and we're going to loft together this one and this line segment that we moved up, and this one that has the slope. So we can just plug those in, but I do like to use a curve component that's empty and place it in here so we know that those are line segments that now we can loft together. So it just keeps it organized. You don't have to do that. That's just a personal preference thing. So once we plug those in, now we're going to flatten the input and it will bring those together, or we'll have to look at how this is organized. So I'll unplug them. When I hover, or when I bring in, let's see if we bring in a panel. This one's organized here where it just says 0, and how this one is organized, it says 0, 0. So what we'll do is we'll graft tree on this one. And when we look at both of the outputs, now they're matching, which means that we don't have to use a flatten loft input. They will be organized in the way that they work together. So I'll actually move this before, plug this in after, and then use these two. I'll keep it organized by aligning it to the right. And this is going to be the base geometry for the stairs. We still have all of the capabilities that we had before, which is going to be the first offset, the second offset, then the height, now we can move into creating the treads. So for the treads, we're going to be using this surface. I'll also use a surface component here. Or geometry component here. Now I'll use a contour. So using this component, contour has 4 different inputs: the shape, which is this one, the point, which is going to be where it starts, and we already have that by using this origin point. And since it's all the way back here, I'll bring it into an empty point component, then bring it over here. Then I'll use the wire display hidden and use this as the input. The direction, since it's going to change depending on the direction of the line segment, we need to understand that we're going to be using this one. So the vector has to be one of these, and it's going to be in the Y direction, in the same direction that we moved the line segment. Now the distance is going to be how far apart the contours are going to be. So we'll go to wire display, hidden for the direction, since it's from all the way over there. We can also use a vector here. Wire display hidden, and then use this over here just to keep it clean. Also, I like to make sure that you guys can use this as well and know where everything plugs in. All right, so the distance is going to be the distance between the treads, no less than 11 inches, or I'll just do 11 less than 16 less than 36. So now that we have that taken care of, now we can extrude them in the same direction that we create the contours. So we'll go to extrude. This is going to be the direction, so we can use an amplitude component. We'll use the contours as the base input to extrude, the vector as the direction. Now we can use the amplitude of the same as the distance of the contours. Notice now that we can hide this geometry, and we've got the stairs started. So there's two ways to continue with this part. One is going to be to take the contours and offset it, or we can offset these surfaces. Now, when you offset a surface, it's going to actually be more computationally difficult than if we just take these curves and we offset them. So let's go to offset curve. It's going to offset up. The only one that it won't do is going to be the last one, because the last one doesn't have a slope, which means that it's going to be using the original plane of this surface as the input. So to fix that, there's two ways to do this. We're going to cull or remove the last step, because technically this would be the last step before you get to the top, or to plug in a specific frame that is a different one than this one, because this is on the ground. So what I'll be doing for this exercise is going to be cull index, which is removing one of the last one here. So I'll go to flatten input. The index is going to be set integer 2 minus 1, which is going to be the last one. Now we can use that as the input. And now we'll be unplugging this, because the extrusion is now going to happen to the curves that we have here. So first, let's do this. Let's offset this by the height of the tread. And we'll also offset this down by a different number. And this is because depending on the fillet that we use, we may actually need to offset it more or less down. So now that we have these two, we're going to join them together by using endpoints. and the endpoints of the offset, and a line segment to connect the start to the start and the end to the end here. We can also loft them together, but this is going to create a cleaner surface. So I'm hiding all of the steps from before. So we can see now we have this line, and the offsets. Now we're going to join them together. So starting with the top one, the two sides, and holding down Shift, I'm adding another input. So you'll see a plus sign. And then this last one. So when we look at the output, we have 15, which is the number of threads that we have. And now we're going to create a surface there. So boundary surfaces. And now we'll take that and extrude it in the same direction that we had before, but this time, since it's a surface, it's going to extrude as a solid. So now let's go here and change the offset from the bottom, and you'll see that at some point, the bottom offset is going to be more. This also has to do with the height that you use for the end. All right, so let's change some of the inputs here. I'll go back and go to the fillet part. And so let's now take the extrusion and I'll plug it into an empty custom preview and bring in a color swatch. So let's now change some of the initial sliders here. Now I see an issue here in the back where it's either selecting it or not. So let's fix that. Let's go back to this curve and let's create a perpendicular frame. Reparameterize it. And now we're going to rotate this because the offset needs to be referencing a plane. And so we can use this frame as the offset plane. If this works. But it's not going to work because it needs to be a frame that it's going the other way. So we'll rotate this frame relative to this plane. by 90 degrees, but by default, it's going to be 0.5 pi, or we can go here to degrees and change this to 90. Now this is going to be the plane or the reference construction plane that we could use to offset those curves. Now we don't need to use this because it will offset that last one correctly. So I'll take this col index, remove it, add that last one. And now when we change it around, we should not have issues. And if we do, it's because it's, see this last one, it's offsetting in the wrong direction. So that has to do actually with the extrude amount. So if we move this here by 241, that should fix that issue. Okay. What's happening is when you create the contours, sometimes the contours will have a glitch at the end when the number lines up exactly with the surface end. And so those are sometimes issues that we can fix by changing the slider slightly. This one, let's see. Also, you could calculate the height based off of the offset and the tread height, and that's going to also allow you to have more control over the stair riser and depth. So the slope determines how tall your tread's going to be, and it also depends on the length of the tread. So those are the things to keep in mind, is that you can, if you have a specific use case or a specific number you want to use, you can plug those in here and everything should work correctly. The other thing is, let's take a look here at the curve input and let's change that. So we've done this parametrically where we can change that location. But the cool thing about doing a script like this is that really you can change all of the inputs. As long as you've done things correctly, you'll see that you can have fun with some of the inputs here. A lot of the things that you see here will be useful for other scripts. So I just wanted to share with you the process for creating this set of stairs. You've seen the entire process, but also some of the limitations, right? Let me know in the comments below what you think about the tutorial. I'll have this available to share with you guys. Thank you very much for being here. Hopefully you enjoyed this tutorial, and I'll hope to see you in the next video.
Plug it in, generate, iterate. Plug it in, generate, iterate. Plug it in, generate, iterate.